हेलो स्टूडेंट्स, जय हिंद। आप लोग कैसे हैं? आई होप यू ऑल आर स्टेइंग वेरी फिट and you are healthy and staying perfectly fine, right? Well, in the previous lecture we have discussed numericals based on impulse and change in momentum. Here in this session we'll continue with those numericals only related to change in the momentum and impulse, right? So let's begin with question number 1. Question number 1 states that a truck starts from rest and rolls down a hill with a constant acceleration. So it must be the case of uniformly accelerated motion. It travels a distance of 400 meters in 20 seconds. Find its acceleration, that's the first part, and find the force acting on it if its mass is 7 tons. So students, I have already advised you while solving numericals, first write down all the information which are given in the question itself, right? So a truck starts from rest. So what is the initial velocity of the truck? It is 0. It's given in the question. Rolls down a hill with constant acceleration. A is constant. It travels a distance of, S is the distance, it is 400 meters. And the time which it takes to cover this distance is 20 seconds. Find its acceleration. A is to be determined and force is to be determined, and mass is given to be 7 tons. Here I must mention ton is the unit of mass. 1 ton is 1000 kg. So 7 tons. So 7 tons means 7 into 1000. So it will be equal to 7000 kg. Students, remember 1 ton is equal to 1000 kg, right? So these are the given informations, and acceleration and force is to be determined. Now look. It's a case of uniformly accelerated motion. So we have to make use of the 3 equations of motion. Out of those 3, we need to make use of any one. S is given, U is known to us, T is known to us, A is to be determined. So it's preferable for us to make use of displacement time relationship. That is the second equation of motion. So from second equation of motion, we know that S equals to ut plus half at square. Substitute the value. S is 400, U is 0. Half, A is to be determined, and T is 20. So 0 multiplied by anything would be 0. So what you get is half into A, 20 square, it will give us 400. So A would be equal to 2 meter per second square. That's the answer of the first part. The acceleration of the truck must be 2 meter per second square, right? Then we are supposed to find out the force acting on it. Students, we have discussed in Newton's second law. It gives the measure of the force, and as a consequence of Newton's second law, the external force acting on a body is given by the product of mass of the body and the acceleration produced in it. Therefore, force will be given by mass into acceleration. Mass is 7000 kg and acceleration is 2. So it will be 14,000 Newton. Don't forget to mention the unit. We are dealing in SI system, so unit of force will be Newton. So acceleration is 2 meter per second square and the force acting on it is 14,000 Newton. So we are over with question number 1, right? Let's proceed with the next question. It's an interesting one. Second question is, a 8,000 kg engine pulls a train of 5 wagons, each of 2,000 kg along a track, right? So it's somewhat like this. This is suppose an engine. This is an engine, right? And it pulls a train of 5 wagons. Suppose these are the 5 wagons. This is wagon 1. This is wagon 2. This is wagon 3. This is wagon 4. And let us consider this to be wagon 5. These are the 5 wagons, suppose. Right? This is the situation and this is the track. So, if the engine exerts a force of 40,000 Newton, it is exerting a force of 40,000 Newton, right? And the track offers a frictional force of 5,000 Newton. Friction means the force which opposes the motion of the body. The train is moving along this direction, so the frictional force must act in the opposite direction. So, this is the force of friction. Force of friction is suppose small f, and this is the force exerted, it's suppose represented by capital F. Force of friction is given to be 5000 Newton, right? This is the diagram. So basically force of friction comes into existence whenever a body tends to slide, roll over the surface of some other body. Then this opposing force comes into play. And force of friction, students, always remember, it always acts in a direction opposite to which the body tends to move. Here the train is moving along this direction, so the force of friction will be acting in the opposite direction. What else is given? We are supposed to find out the net force, right? So what will be the net force? This one is dominating on this 40,000, this is 5,000. Both are oppositely directed. So they are opposing each other. And this being dominant, net force will act along that direction. And net force will be given by 40,000 minus 5,000. Why this negative sign? Because both the forces are opposing each other, right? So resultant would be dominant force minus the opposite force along the direction of the dominant force. That's the net force. So it will be equal to 35,000 Newton. So that's the answer of the first part. What is the acceleration of the train? Now we are aware net force is equal to mass into acceleration. So acceleration would be net force acting on the train divided by mass of the train. What is the net force acting on the train? That is 35,000, right? What is the mass? Mass of the engine is 8,000, right? It is 8,000 kg. And each of the wagon is 2,000 kg. 2. So it will become 10,000, isn't it? 10,000 plus 8,000, it will be 18,000. Am I clear, students? This M is the mass of the entire system, which includes the engine along with the 5 wagons. Each wagon is of mass 2 kg, so 5 wagons will weigh 10,000 kg plus 8,000 is the mass of the engine. So total mass of the system would be 18,000, right? So this will be the answer. It will be in meter per second square. So you can easily solve it. So it will be equal to 35 by 18. So that comes out to be about 18 to 36. So it will be about 1.9 something meter per second square. Is it clear, student? So that's the acceleration and this is the net force acting on the train. Right? It was quite simple. Okay, students. Third one. We are done with question number 2. Third one is quite important. So concentrate on the third question then. Two objects, each of mass 1.5 kg, are moving in the same straight line but in the opposite direction. Okay, let's represent this question diagrammatically, right? Third question. So it's somewhat like this. This is a body of mass 1.5 kg. The velocity of each object is 2.5 meter per second. It is 2.5 meter per second. This is m1. This is u1, suppose. This is another body of mass m2, identical, that is, it will also have a mass of 1.5 kg. They are moving in the opposite direction. Its velocity is also 2.5 meter per second, moving along the same straight line but in the opposite direction. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. What happens is after collision, they tend to stick together like this. It means that they will act as a single body. They will act as a single body, right? What will be the velocity of the combined object after collision? So we are supposed to find out the velocity of this combined mass. V is to be determined. Now what is the mass, combined mass? It will be m1 plus m2. It will be m1 plus m2, which will be equal to 3 kg. So this needs to be determined, right? So these are the two identical bodies, each of mass 1.5 kg, moving along the same straight path but in the opposite direction, each having velocity of 2.5 meter per second. And in the question it's given that after collision they stick together. So after collision, what will be the final velocity of this combined mass? So students, there is no net external force acting over it. They are exerting force upon each other. During collision, they definitely will exert force upon each other. But those are the paired forces, equal and opposite pairs. We are aware of Newton's third law. To each and every action, there exists always an equal and opposite reaction. Forces in nature always exist in equal and opposite pairs. So these are the internal forces in this system. So they tend to, net force acting in this system is zero. No net external force is acting on it. Clear, students? So, they are only interacting due to the mutual interaction between them. So what I mean to say is that whenever no net external force acts on a system, then as per the law of conservation of momentum, the net momentum of the system always remain conserved. What I mean to say is that initial momentum of the system is equal to the final momentum of the system. That is, since net external force is equal to 0, it implies that momentum is constant. That is, initial momentum is equal to final momentum. Right? Therefore, what is the initial momentum? m1u1 plus m2u2. Right? Now here, you must note down that u2, on substituting the value of u2, it has to be put negative sign. Why? Because they are moving in the opposite direction. If this is taken as positive, then this direction needs to be taken as negative. And what about the final momentum? It is m1 plus m2. This will act as a combined mass and its final velocity is v. So therefore, now let's substitute the value. As I told you, u2 is to be replaced by minus u2. This is a key point. This is a very, very important point. Why this negative sign? Because the bodies are moving in the opposite direction. Velocity is a vector quantity. If this direction of motion is taken as positive, then this direction of motion will be taken as negative. In case both the bodies are moving along the same direction, then no need to assign this negative sign. Clear? Negative sign is to be assigned only when the direction of motion of the two bodies under consideration is opposite to one another. So let's substitute the value then. So the common velocity, or rather the velocity of the combined mass after collision, it would be m1u1 minus m2u2 divided by m1 plus m2. So let's substitute the value. m1 is 1.5, it is 2.5 minus 1.5 into 2.5 divided by m1 plus m2, that is 1.5 plus 1.5, that is 3. Now the numerator is 0, therefore v would be also equal to 0. So what do you conclude from this? After collision, the two bodies will stick together and they will come at rest. The final velocity of the combined mass will be 0. That is what we have proved. That is, after collision, the two bodies not only stick together, but they come at rest. Right? So, this was a good question. So, we are done with question number 3 as well. Okay, students, let's proceed to the next question. Question number 4. A hockey ball of mass 200 gram traveling at 10 meters per second is struck by a hockey stick so as to return it along its original path with a velocity of 5 meters per second. Calculate the magnitude of change of momentum. Okay, this is related to question number 3 only. Okay, this is the hockey stick, suppose. This is the hockey stick. A ball is coming like this. It is being struck by the hockey stick and it moves in the same direction. It moves, or it rather retraces its path in the opposite direction. So, if this is its initial direction of motion, then after getting struck by the hockey stick, it will retrace its path in the opposite direction, returns back. So it is returned, so as to return it along its original path with a velocity of 5 meters per second. So this velocity is given to be 10 meters per second and this velocity is given to be 5 meters per second. Right? And ball of mass 200 gram. The mass of this ball is 200 gram, which will be equal to 200 divided by 1000 kg. That is mass, it will be equal to 1 by 5 kg, right? So it will be 1 by 5 kg. This is the mass of the hockey ball which is given in the question. Mass will remain same. It will be 1 by 5 kg. Now, what we are supposed to calculate is calculate the magnitude of change of momentum. Students, change of momentum is final momentum minus initial momentum, right? So let's find out. So change in momentum. Change in momentum is PF minus PI. Final momentum minus initial momentum. Final momentum is MV. Initial momentum is MU. So it will be MV minus U. Right, students? Okay, this is to be found. Now in this case, again, this is the initial direction of motion, and after getting struck by the hockey stick, this is the final direction of motion. So students, both are of opposite direction. So therefore, what to do? We need to take one velocity as negative. So if you consider this to be the positive direction, it's your wish. If you consider this to be the positive direction, then this would be taken as negative. Students, it's entirely up to you to consider positive, to consider the direction towards right to be positive and towards left to be negative, or vice versa. It's entirely upon you, right? So here I consider this to be positive and this direction to be negative. So since they are having different directions, opposite directions of motion, so one needs to be assigned positive sign while the other needs to be assigned negative sign. So this is the final velocity. Mass is given to be 1 by 5. Final velocity. This direction is considered to be negative, so it will be minus 5. This is a key point, student. In place of V, don't write 5. This is initial velocity, this is final velocity. But here, substituting the value, you are supposed to write V as minus 5. Because it is moving in the opposite direction. Minus U, this is considered to be positive, so plus 10. Right, students? So what you get is 1 by 5 multiplied by minus 15. So it is minus 3. And unit would be momentum, mass into velocity, kg meter per second. So in magnitude, change in momentum, it can be represented like this. Del P, it represents change in momentum. Final momentum minus initial momentum. This is mod. Mod means magnitude. We are supposed to find out the magnitude. So magnitude of the change in momentum is 3 kg meter per second. So that's the answer. I hope students you have understood the concept. In question number 3 and 4, again let me remind you the very fact that if the two bodies are moving in the opposite direction, or if a body after getting struck by a wall or a hockey stick tends to retrace its path in the opposite direction, then the direction, or rather the sign is to be assigned, negative sign is to be assigned, right? If this direction of motion is considered positive, then the opposite direction of motion is to be assigned negative sign. So that is what we have made use of in question number 3 and question number 4. Please do remember it. So we are done with question number 4 as well. Let's concentrate on question number 5. It is based on the equations of motion as well as the consequence of Newton's second law. Okay, fifth question is, how much momentum, we are supposed to find out the momentum, will a dumbbell of mass 10 kg, mass is given to be 10 kg, transferred to the floor if it falls from a height of 80 cm. This is a floor and this is an object. It falls through a distance of 80 centimeter, right? Height of 80 centimeter. So let's convert it in meters. So 80 by 100 meters. This is the distance, right? It falls through this distance. So it falls. During the free fall, we are aware the initial velocity of the body is 0. Just drop it like this. So during the free fall, the initial velocity is 0. So when it just strikes the floor, then velocity can be calculated. And then what we are supposed to do is, downward acceleration is considered to be acceleration is considered to be 10 meter per second square, right? So we are supposed to find out the momentum. So what is momentum basically? That it will transfer to the floor, it will be mass multiplied with the velocity with which it will strike the floor. This is to be found. Mass is known to us, final velocity is to be determined, right? So S is given, V is given, U is given, A is given. So we can make use of the third equation of motion. So using third equation of motion we get 2as is equal to V square minus U square. So let's substitute the value 2, A is given to be 10, S is given to be 80 by 100, isn't it? V square, this is to be found, minus U is 0. So let's solve it. 0, 0, 0, 0 get cancelled. So 16. So V would be equal to plus minus 4. So taking positive sign we get 4 meter per second. In fact, 4 meter per second, isn't it? So the velocity with which the object hits the floor is 4 meter per second. So now coming back to the momentum, it is mass into velocity. Mass is 10 and the velocity at the instant of striking the floor is 4. So it will be 40. Unit would be, unit of mass is kg and unit of velocity is meter per second. So this is the answer, student. This much momentum will be transferred to the floor by that object when it falls through a given height, right? So this is how you need to proceed. Okay, let's discuss, the fifth question is also over. Let's discuss question number 5. Fifth one is also pretty important one. Okay, it's the case of a bullet of mass 10 kg which is traveling horizontally with a velocity of 150 meter per second and it strikes a stationary block and obviously it will come to rest in 0.03 seconds. We are supposed to calculate the distance of penetration and the magnitude of the force, right? So this is it. This is suppose the wooden plank. This is the wooden plank. So bullet is fired. As it enters the wooden plank, its initial velocity is given to be 150 meter per second. 150 meter per second. Now look, as it penetrates inside the wooden plank, its velocity obviously will keep on decreasing and eventually suppose at this point it comes to rest, right? So we are supposed to find out this distance of penetration. Calculate the distance of penetration. This distance of penetration is to be found, right? So initial velocity is 150 meter per second and V is it is 0, final velocity. And during what time its final velocity becomes 0? That is 0.03 seconds. So these are the given information. So mass of the bullet is also given. It's given to be 10 gram. Don't forget to convert it in SI. So it will be 10 divided by 1000 kg. Right, students? Okay. U is given, V is given, T is given. So using first equation of motion. This is first equation of motion, which is also known as velocity time relationship. Final velocity is 0. Initial velocity is 150. A is to be determined and time is 0.03. During this time, the bullet comes to rest, isn't it? So 0.03 A is equal to minus 150, or A would be equal to minus 150 divided by 0.03, isn't it? So it will be minus 150 into 100 divided by 3. So that will give you minus 5000 meter per second square. This is the acceleration. And negative sign in the acceleration means that obviously it is the case of retardation, right? So A is minus 5000 meter per second square. Now calculate the distance of penetration. Once we are able to get A, then we can make use of, I think, S equals to ut plus half at square, or we can make use of V square minus U square is equal to 2as. So it's your wish to make use of any of the equations of motion. So let's make use of this equation. 2as is equal to v square minus u square. This is from third equation of motion. So let's substitute the value. 2, what is the value of a? It is minus 5000. S is to be determined. It is the distance of penetration. What is v? It is 0. What is u? It is 150. So S is equal to minus 150 into 150 divided by 2 into minus 5000. Minus minus get cancelled. This 0 get cancelled. This 0 get cancelled. 15 square, that is 225 divided by 100. So it will be equal to 2.25 meter. So this is the distance through which the bullet will get penetrated inside the wooden plank. Right, students? What else is to be found? The magnitude of the force. It's simple. As per the Newton's second law, the consequence of Newton's second law, the measurement of force is equal to mass into acceleration, isn't it? So, force would be mass is 10 gram, that is 10 by 1000 kg. Multiplied by what's the acceleration? It's minus 5000. So, that will give you minus 50 Newton. Minus sign indicates that it is a retarding force, right? So, we are over with question number 6 as well. So, students, I hope you must be enjoying doing such questions. Please develop interest in physics, and that can be done only by practicing more and more numericals. So, once the theoretical concepts gets clear, do practice more and more numericals based on the learned topics, right? So, students, all the very best. Study well and do take very good care of yourself. Thank you.